Einstein's Relativity, Part 2, Simultaneity. In his book, Relativity, the Special and the General Theory, Einstein states, "When we say that the lightning strokes A and B are simultaneous with respect to the embankment, we mean the rays of light emitted at the places A and B where the lightning occurs meet each other at the midpoint M of the length A and B of the embankment." Einstein is setting us up for confusion here. Simultaneous is given whether it looks simultaneous or not. Einstein told us that the two flashes are simultaneous. Having said this, I will entertain Einstein's thought experiment, which he discusses extensively in his thought experiments. If two observers, green and purple, each with a clock, are next to each other, an equal distance between two distant flashes, red and yellow, that light simultaneously, both observers will see the flash at the same moment on their clocks. If green was 150,000 kilometers closer to red and purple was 150,000 kilometers closer to yellow, then green would see the red flash before the yellow flash, and purple would see the yellow flash before the red flash. Galileo's mechanics would say there would be a 1-second spread between the receptions of the two flashes for both observers. If purple remained stationary at the second location, the 1-second spread between the flashes would show at purple whenever the two lights flashed at the same time. If green passes the red flash and continues moving away from red, purple, and yellow, the time interval between flashes on the green clock would be greater than 1 second. If green accelerates in the same direction, the time interval between flashes on the green clock would continually vary upward, depending on its speed. This thought experiment shows that there is a wide range of variation in time interval between flashes of light that are given as simultaneous in the postulate of the experiment. So far, Galileo and Lavaggi agree with Einstein. Now consider this thought experiment. There is no red flash. Yellow lights for 1 second and extinguishes. Purple will see the yellow light for 1 second. The 1 second of light will be a stream of light 300,000 kilometers long from its leading edge to its tail. The 300,000 kilometer stream of light will catch green that is separating from purple. Depending on the speed of green, the 1 second interval between the beginning and the end of the light signal will take longer for the stream to pass green. In the spirit of a thought experiment, how long would it take for the 3,000 kilometer light stream to pass green if green was separating from purple at a speed of 150,000 kilometers per second? Without the ability to observe this experiment empirically, Galileo and Lavaggi would say, with due humility, probably 2 seconds. Special relativity claims that the 300,000 kilometer stream of light will pass green in 1 second, regardless of the speed of green. Special relativity claims that the clock traveling with green would be time dilated because of its relative speed. Thereby, the light would pass green in 1 second relative to the dilated clock.